Welcome to G Fun Facts Online. In the silent, dark depths of our oceans, a new gold rush is beginning. Not for gold, but for the minerals needed to power our smartphones and electric cars. This race to the bottom, known as deep-sea mining, promises a new era of technological progress. But it comes with a hidden, potentially catastrophic cost, a phenomenon scientists are calling the junk food effect. It's a story not of explosive destruction, but of silent starvation, where we could inadvertently replace the lifeblood of the deep ocean with the equivalent of empty calories, triggering a devastating ecological collapse. Today, we unravel the story of the junk food effect and the deep-sea mining threat. Far below the sunlit surface of the ocean, between 200 and 1,000 meters down, lies the mesopelagic zone, better known as the Twilight Zone. It's a world of immense pressure, cold temperatures, and perpetual, faint blue gloom. For a long time, we thought of it as a vast, empty space. We couldn't have been more wrong. Recent studies suggest the biomass of fish in the Twilight Zone could be 10 times greater than previously thought, potentially outweighing all other fish in the ocean combined. This realm is filled with bizarre and wondrous creatures, many of which create their own light through bioluminescence, painting the darkness with silent signals. They have huge, sensitive eyes, often pointed upwards, to catch the faintest silhouette of prey against the dim light from above. The Twilight Zone is not an isolated world. It's a critical hub. It's connected to the sunlit waters above and the abyss below by the largest animal migration on Earth. Every single night, countless fish, squid, and crustaceans journey upwards to feed at the surface, and every dawn, they descend back into the depths to hide. This daily commute is vital. It's the engine of what's called the biological carbon pump. These animals, along with a constant shower of dead plankton and other organic debris known as marine snow, transport vast amounts of carbon from the atmosphere into the deep ocean. This marine snow is the primary food source for the Twilight Zone. It's the foundation of its entire food web. By absorbing carbon at the surface and sinking it, the ocean acts as a massive buffer against climate change, and the Twilight Zone is its crucial engine room. So why are we now proposing to industrialize this vital, fragile world? The answer lies on the sea floor. The deep seabed is a treasure trove of minerals. There are potato-sized polymetallic nodules rich in nickel, copper, and cobalt, lying across vast abyssal plains. There are seafloor massive sulfides, formed by hydrothermal vents, loaded with copper, gold, and silver. And there are cobalt-rich crusts coating underwater mountains. To harvest these, giant remotely operated vehicles, essentially underwater bulldozers, would crawl across the seafloor, sucking up nodules and the top layer of sediment, or grinding and blasting the crusts and sulfide deposits. This material is then piped up thousands of meters to a surface vessel. But what happens to the waste? That's where the problem starts. The mining process generates enormous plumes of sediment. This slurry of fine rock, sediment, and water is discharged back into the ocean. Some of it is released near the seafloor, but a huge volume is planned to be released in the midwater, directly into the Twilight Zone. A single mining operation could discharge tens of thousands of cubic meters of this sediment-laden water every single day. These plumes don't just disappear. They can spread for tens or even hundreds of kilometers, creating a persistent, murky cloud that can hang in the water column for months or years. And this cloud is the source of the junk food effect. Here's the core of the problem. The tiny drifting animals at the base of the Twilight Zone's food web, the zooplankton, are not picky eaters. They filter feed on particles in a certain size range. The sediment particles in these mining plumes are almost identical in size to their natural food, marine snow. There's just one crucial difference. The mining waste is nutritionally worthless. A study in Nature Communications found these mining particles contained virtually none of the amino acids and lipids that make marine snow a life-sustaining food source. So, as the Twilight Zone fills with this cloud of waste, The zooplankton begin to ingest it. They are filling their stomachs with useless sediment. It's like a person trying to survive on a diet of cardboard. You might feel full, but you are slowly starving to death. This dietary dilution has severe consequences. Malnourished zooplankton can't grow properly. They have fewer offspring, and eventually their populations crash. But it doesn't stop with zooplankton. This is the first domino in a trophic cascade. Zooplankton are the primary food for a vast array of small fish, shrimp, and squid, known as micronectin. When zooplankton populations decline, or when the zooplankton themselves become less nutritious, the micronectin also begin to starve. Their populations suffer, and the cascade continues upwards. Micronectin are the prey for commercially important fish like tuna and swordfish, as well as deep-diving marine mammals and seabirds. A collapse in their food source could be devastating. It could lead to a sharp decline in fisheries that millions of people depend on. One study projected that as climate change pushes tuna populations into the Clarion-Clipperton Zone, a prime target for deep-sea mining, the conflict between fishing and mining will intensify, with mining plumes directly threatening the food and breathing ability of tuna and their prey. The entire interconnected food web, from the tiniest plankton to the largest predators, begins to unravel, all because of this junk food. As if starvation wasn't enough, these sediment plumes carry another threat: a toxic cocktail of heavy metals. The mineral deposits being mined are naturally rich in metals like copper, cadmium, zinc, and lead. The mining process grinds them up, releasing these metals into the water. These metals are toxic, even at low concentrations. The fine sediment can clog the gills of fish and other organisms, causing respiratory distress. The metals themselves can disrupt reproduction and alter behavior. Even more worrying is bioaccumulation. Zooplankton ingest the contaminated particles. Small fish eat the zooplankton. Larger fish eat the small fish. At each step up the food chain, the concentration of these toxins increases, a process called biomagnification. By the time these toxins reach top predators like tuna, or the whales and dolphins that feed in these zones, they can be at dangerously high levels, posing a threat not only to the animals, but also to any humans who consume them. The impacts of deep-sea mining won't be temporary. The deep sea is a world of incredibly slow processes. Recovery from this kind of disturbance could take centuries, if not millennia. We have proof of this. A simulated mining experiment was conducted in the Peru Basin in 1989. A study looking at the site 26 years later found the plow tracks were still perfectly visible on the seafloor. The microbial communities, the very foundation of the ecosystem, had not recovered. Their ability to process carbon was still significantly reduced. Another test site in the Clarion-Clipperton Zone, studied 44 years after a mining test, still showed lower biodiversity than undisturbed areas. Mobile animals were slowly returning, but the large, stationary life forms were gone. The regulatory body in charge of this new frontier is the International Seabed Authority, or ISA. It's tasked with creating a mining code to govern exploitation in the international seabed, an area legally designated as the common heritage of mankind. But the process is mired in controversy. Many scientists and a growing number of countries are calling for a moratorium, a temporary ban on all deep-sea mining. They argue we simply don't know enough about the deep ocean to proceed safely. This is the precautionary principle in action. When an activity poses a threat of serious or irreversible harm, a lack of full scientific certainty should not be a reason to postpone measures to prevent that harm. The junk food effect is a stark warning. The deep ocean is not a barren void to be plundered, but a complex, vital, and fragile ecosystem that plays a critical role in the health of our entire planet. The decisions we make now, at the dawn of this new industrial age, will determine its future. Will we sacrifice the largest and least understood biome on Earth for short-term mineral demand? Or Will we heed the warnings, embrace precaution, and protect the silent, vital world of the Twilight Zone for all generations to come? The depths are waiting for our answer.